Okay. Right. Tony, Mina, and Pony, yes? You're late because you're doing maths in the canteen, yeah? Yeah, of course, of course. Okay, so we'll start now. So this is the last chapter for semester 1, and it's about probability. This is a word that you might already know. So the example everybody knows is when we flip a coin. Come on. It can either land on heads or it could land on tails. What? Don't laugh at my coin, okay? Look, it's a euro coin and everything. So it either lands as heads or tails, and you all have an understanding that there's a 50-50 chance for the heads or for the tails. Okay, so this is kind of our basic understanding about probability. So just a little bit, just to be clear, when we talk about probability, we're talking about giving something a number between 0 and 1. So with the example of the coin, you kind of understand already that you've got a half chance of getting heads and a half chance of getting tails. But everybody naturally understands that. So just to be clear, what would a 0 value mean? If I said the probability is 0, what am I saying about the event? Say again? Yeah, but more stronger than that. It's impossible to happen. So it just simply cannot happen. So this is impossible. And then at the other end, if the p is equal to 1, what would that mean? Stronger than that. Certain. Guaranteed. Must happen. And then some value in between means some value in between. 50% means it could happen half the time. So probability must be between 0 and 1. It could be 0 and 1. It's usually not 0 or 1. So how can we calculate probability? Well, with the example of the coin, we need a bit more vocabulary. So with the coin, we say that the coin is fair. What does that mean? Fair coin. Any ideas? Say again? Yeah, not modified, yeah. Make it a little simpler for me though. Fair. So yeah, you're not modifying the coin in some strange way. Something simpler though, fair. Yeah, but I want simpler words, not more difficult. Yeah. So fair means every possibility is equally likely. So each outcome is equally possible. So as you said, Victor, it's not like you modify the coin so that the heads is more likely than the tails, or as you said, it's not biased. Every outcome is equally likely. So that's what we mean when we say fair. What's the opposite of fair? No. It should be unfair, but it's not. In fact, Remo, you said the word earlier. Biased is the opposite of fair. So I'll put it in quotation marks. unfair. So what do you think unbiased means? Yes, fair. So, these are bad things about English. So fair, its opposite is biased, and the opposite of biased is unbiased, also means fair. Yes. So the reason I'm telling you this is because in the question they might use one of these words, fair, biased, unbiased. So fair and unbiased is the same. Okay. We won't really look at this one until semester 2. So for this semester, we kind of keep it a little simpler. Okay, so how can we calculate probability? So for example, if I want the probability of the coin landing heads. Oh yeah, and I should say, I like to use this symbol for probability. So this here means the probability of. So it's not quite P. Really, it's P that looks like this with the 2 lines. Okay. So, what is the probability of getting the coin to land heads? Well, I think everybody understands that it's 1 over 2. But why is it the 2 and why is it the 1? So why do we write 2 down below? 2 possible outcomes, yeah. 2 outcomes. And why 1 here? Only 1 outcome is the outcome that you want. So this is how many, the number of outcomes that you want.
The chances?
Yeah, the number of opportunities. Now you have to be very careful though. So for example, if I have 2 coins, euro coin and euro coin, so what's the probability of them both being heads? Anybody think they know this one? Half? Quarter?
Half.
Well, be very careful. Some people, well, which is it, half, quarter, or something else?
You might like have
half, quarter. Why not 1 over 3? How many outcomes are there? Well,
different.
you can get 2 heads, 2 tails, or you can get a heads and a tails. So you have to be very, very careful. When I say the number of outcomes, you mean all possible outcomes, even the outcomes that look like they're the same. Because of course you can get heads or tails, or tails and heads. And I know those 2 outcomes will look the same. If you look at a table, 1 coin is head and 1 coin is tails. You don't care that the first one was heads and the second one was tails. But they are 2 different possibilities. So just be very careful when you're counting the possibilities. So this, by the way, it's not 1 over 3 and it's not 1 over 2, it's 1 over 4. But we'll get to that in a minute. So we have this notion called a sample space. Okay, so please make sure you've got this vocabulary. Sample space. Does anybody know what a sample space is? Have an idea? No? Anybody want to have a guess?
the amount of data you have.
Maybe something related to the data. Although we're not talking about data just yet. Anything else? No? So sample space is a list of all the possible outcomes. Okay? So for example, if I have a What's this called, by the way? This is 1, 2, 3. And you roll it. What's it called? Spell. It's called this? It's not. Very good. It's called a die, and when you have two of them, they're called dice. Yeah, this is a common mistake a lot of people make. So, two of them together, 2 dice. Yeah? You're unhappy with this? It's a very, very, very common mistake even for native speakers. Die is single and dice is plural. Okay? Just like man and men. Irregular noun. Yeah? Okay. So, what is the sample space here? Hang on. 1, 2, 3. 1, 2, 3. So here you have this possibility. 1, 2, 3, 4, 5, and that's a 6. So this is the sample space. There's 6 things in the sample space. What about the sample space here? It's a lot bigger, isn't it? The first one could be a 1, and then you could have a 1. The next one could be a 1, and this one could be a 2. And it'll continue. It'll be quite long. And then we finish on a 6 and a 6. Does anybody know how many possibilities there are here? Very good. There's 36 here, whereas here 6. So, for example, if I said, what's the probability of getting a 6? No, we'll say a 4. Well, there's only one outcome here, so that's 1 here. And we divide by how many outcomes we have, which is 6. Now, let's say here, what's the probability that the total is 3? So what I mean by the total is you add the 2 together. So here the first total is 2. The next total, 3. Okay, so we know that there's 36 on the bottom, but what's on the top? Very good, 2, because there's 2 events that make the result we want. We could have a 1 and a 2, or a 2 and a 1. Both will give me a total of 3. Now what about if I make it a little bit more difficult? If I said a total is 4. The total, that when you roll the 2, they add to make 4. Well, let's see how many events make the result we want. So we could have a 1 and a 3, 2 and a 2, and then a 3 and a 1.
How many times do you throw them?
You throw the 2 together at the same time. So there's 2 dice, and there's 2 numbers to add. So there's only 3 events that give you a total of 4. So in here it's 3 over 36. Yeah? So I know this can be a little bit confusing maybe to get your head around. So what I'll do is we'll do some of these questions together, okay? Oh yeah, I'll just do one more here. What is the probability that the total is 13? 0? What's... You can't make 13. The maximum is 6 and 6. Yeah? Right? You can't make 13, right? Yeah? Okay, let's do some of these questions together. So can you have a look at page 86? Okay, let's have a look at the, oh sorry, do you need to write this down? Right. A fair coin is tossed twice and the results recorded. What is the sample space of this? Can I do this one? Yes? Yes? Okay. Alright, so let's have a look here. 1A. The sample space. Heads, then heads. Heads, then tails. Tails, then heads. Tails and tails. Okay, B. What is the probability that you get the same results on both coins? Yeah, well, let's just put in the details. So divide by 4, because there are 4 outcomes, but only 2 of them is what we want. The answer is 1 over 2. And C, the probability of 1 heads and 1 tails. What will that be? It'll be 2. Because it'll be this or this. Is a heads or a tails. You don't care which. Now, I suppose if I add in an extra part, if I said the probability of a heads then a tails, what would that be? 1 over 4, because this event is you get a heads first and then you get a tails second. So this is heads then tails. Whereas here, a heads and a tails, you don't care if it's heads tails or tails heads.
That's how it's like,
Mm-hmm.
I mean, if you throw this.
Yeah, this is one coin, and you throw it twice.
Okay.
Yeah. So the last one is a heads, then a tails. Okay, do we get the basic idea? Let's have a look at another one now. Number 2. So a coin is tossed 3 times. What's the sample space? So you can have heads, heads, and heads. Heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Oh my goodness, who's making so much noise with their chocolate? Yes, yes, who is doing that? Tails, heads, heads. Tails, heads, tails. Tails, tails, heads, and finally tails, tails, and tails. Okay, that's part A. What's the probability of getting 3 heads? 1 over 8. There are 8 outcomes, and only one of them is what you want. Okay. Okay, so now what we'll do is I'll let you try the question for 1 minute before I do the answer. I think you all have the idea here. So just for 1 minute, try number 3, and then I'll do it on the board. Okay, nearly finished. Yeah? Let's have a look. So in this question, a woman, not a woman, goodness, a woman gives birth 4 times to 4 children. And the reason I say that is there's no twins. So each child is 50-50 chance of being male or female. What is the sample space? So we have the worst case, 4 boys. Oh yes, worst case. And then you could have male, 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 female, male, male, female, male, and then you can have male, male, no. Yes, female, female. Then you can have male, female, male, 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 female, male, female, male, female, female, male, male, female. No, don't confuse me. Sorry, male, female, 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 and then again female, male, 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 female, male, male, female. Okay, I'm on a roll now. Male, female, male, female, male. I was on a roll. Female, male, female, male. Actually, it's easier if I just say boy and girl. Girl, boy, boy, girl. Oh. Hang on. Let's go back a bit. Right, let me go back more. Okay. Female, male, male, male. Female, male, male, female. Female, male, female, male. Female, male, female, female. Female, female, male, male. Female, female, male, female. Female, 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 male. Female, 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 female. Goodness. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Perfect. So there's 16 possibilities here. From the worst possibility to the second worst possibility. What is the probability that you will have 2 boys and 2 girls? Yep. So how many possibilities is that now? You had a question? Yeah.
Why you consider the order? Because it's only for one time.
No, so it's 4 different children, 4 different times. So it's like 4 coins, 4 coin flips. The order is important because you can think about each child as having a name. So you can have Anne, Barry, Charlie, David, so, or whatever, A, B, C, D. So the first child is a male, second one's a male, third one's a male, fourth one's a male. That's different to, well, it's quite different to this one here. I need to look at what happens each time there's a child born, because there's 16 different situations for the family. So here, for example, in this situation, the eldest child is a boy. In this situation, the eldest child is a girl. Yeah. Which situations do we want? So, no, 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 yes, no, yes, yes, no, no, yes, yes, no, yes, no, no, no. So there's 6 out of 16, or 3 over 8, is the probability of you that you'll have 2 boys and 2 girls. But she doesn't care, you know, if the eldest is a boy or a girl. She just wants 2 boys and 2 girls, and it doesn't matter if the first 2 are boys or if the last 2 are boys. So the order is not important here. So she has a 3 out of 8 chance. Now it's funny because when I was doing this question, I remembered that I have a friend who says they want to have 4 children, 2 boys and 2 girls, and she just gave birth to child number 3. So far she has first child, boy, second child, boy, and her third child, boy. So now she has a 50-50 chance of the situation no mother wants. 4 boys. Just too much work. Too much work. No, really, too much work. Okay. Can you have a look at number 5 now? Can I scroll down? So I want to draw it for you what's happening. So in number 5, you have a bag, and in the bag is 1 red, 1 green, and 1 blue ball. And you take it out one at a time. But what's really, really important to note in the question, it says without replacement. Now, what do I mean when I say without replacement? Does anyone know what this means?
When I take one, I don't get it back.
That's right. Without replacement means when you take 1 ball out, you don't put it back and take another one. So what's happening here is there's 3 balls and you take 1 and then 2 and then 3. But you never put them back. Sometimes these problems are with replacement. So you take 1 ball out, you look at it, and then you put it back. Okay. Right, so I want you to try number 5. I want the sample space and then the probability that you finish on red. So this one isn't as long as the last one. How many possibilities are there in the sample space? 6, yeah. You can go red, green, blue, red, blue, green, blue, red, green, blue, green, red, and then green, red, blue, green, blue, red. So how many of these possibilities finish on red? 2. No, so what the heck? No. Here and here, isn't it? So you have a 2 out of 6 chance, or a 1 out of 3 to finish on a red. Okay, try number 6. The only difference with number 6 is this time it's with replacement, which will change the answer. So try number 6. finished? Okay, will we have a look at this? Yeah? Right. So now the sample space. Have any possibilities? 27. Right, let's do this. Red, 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 green, red, red, blue, red, green, red, red, green, blue, red, no, blue, green, green, thank you, red, green, green, red, blue, red, red, blue, green, red, blue, blue. Now we'll take a little shortcut because we know that we have to repeat this, except the only difference is this time we start at green. So we have green, red, red, and then green, red, green. So here, how many do we have? 1, 2, 3, 4, 5, 6, 7, 9. And then when I repeat it, 9. And then again, repeated one last time, except this time here we have starting with blue, red, red, blue, red, green, and here we have 9. So here we finish on red 1, 2, 3 times. And here it'll also be 3 times, and here also be 3 times. So the total is 9 over 27, which quite interestingly in this example here it's still the same probability. So you still have a 1 in 3 chance of finishing on red, which maybe would have surprised you because you feel like the difference is a big difference, and it is a big difference, but for this problem it's still a 1 in 3 probability that you finish on the red ball. Yep. Okay, try number 7. I want to see what you get for number 7. Got an answer? What did you get? Huh? 1 over 3, I believe so. Did you get an answer? What did you get? 1 over 3? Very good. Let's have a look at it here. So in this one you have 3 children, I think, isn't it? Yeah. Tall, medium, and short. And you want to know if they stand in a line, what's the probability that they stand in order of their height? So there's 6 possibilities here. We'll have tall, medium, small. So they can stand tall, medium, small, tall, then small, then medium, medium, tall, small, medium, small, tall. This last time, so small, medium, tall, small, tall, medium. So there's 6 possibilities. How many of them do we want here? 2, because this one here and this one here is when they stand in order. This one here is they stand tall, medium, and small, but this one here is small, medium, and tall. They're in order as well. I tried to trick you a little bit. I never said in the question if they're standing left to right or right to left. It doesn't matter. In both cases, they're standing in order from tallest to smallest, from tallest to smallest. So actually it's 2/6 or 1/3. If you gave me an answer of 1/6, you fell for my trick. Okay. But a lot of you said 1/3, which is good. Okay, so actually what I'll have you do now for the last 10 minutes is to finish these questions, okay? I just did half of them really slowly. You'll be able to finish them in 10 minutes, I'd say. So whatever you don't finish now, you have to finish for homework. They're not, the longest part of the question is the sample space. But if you can think of a way to make a shortcut like I did here, I'm okay with that. Just be careful in the exam though, okay? Alright, try these for 10 minutes. Can I close this?